The only thing that we really haven't looked at yet are piecewise functions. And I've avoided them because you're afraid of them. But they're actually one of the easier ones. Because when you see that symbol indicating a piecewise function, you know that there's a possibility you could expect a what? A jump. That's what they're known for producing. That's what they do, is kind of a jump discontinuity there. The other thing about piecewise functions that's nice is it already divides it into the left and right side for you. The top piece, where x is less than a number, is the left piece. The bottom piece is the right piece. So the great thing about piecewise functions is you don't even have to graph them. You can look at them and tell which piece to use. So if I give you a piecewise function, this one right here, and I ask you to find the limit as x approaches 2 from the right, because it's a piecewise and it's already broken into pieces for you, left and right pieces, all you have to know to do is to figure out which one of those is going to handle the right side of 2, where it's greater than 2 or where it's less than 2.
Bottom.
Right. Most people, I included, will always put the left piece on top and the right piece on bottom. I cannot say for sure though, so you do not need to get in a habit because other instructors may not do that. If they had put greater than 2 up here, that would be the right piece. So you just have to look and decide which one is the right piece. So this is the right piece, and then you ignore this entirely. If you are looking for the right-sided limit of a piecewise function, you simply plug 2 into the right piece and see what you get. So if I plug 2 in right here, what do I get? 2. I get 2 squared plus 1 equals 5. Bam. There is your right-sided limit. So the ones that you've always hated before suddenly become very nice in our study of limits because it's so easy to look at. Any questions about that part?
So if it was just a plain limit, no left or right side, it would not exist, right?
I don't know because that's part C and we haven't gotten there yet. Okay. All right. Now, let's take a look at the limit as x approaches 2 from the left. If we're approaching from the left, we only want to look at the left side of that. So this is our left piece. This says that everywhere left or equal to 2, that this function value is equal to 7 minus x. So that's our left side. Oh my. This is our left side, and as we're coming in from the left, it looks like 7 minus 2 is 5. So here's the moment of truth. If you check the little, which one did we do first? If you check the right limit, and it equals 5, and you check the left limit, and it equals 5, what can you say about the two-sided limit?
It's 5.
It's 5. So that is so easy. If you want to know the limit, plug into the top, plug into the bottom, figure it out. That's how you find the limit at a breaking number of a piecewise function. Piece of cake.
And I'm guessing.
May we have your attention?
So for your final problem, we want to find the limit as x approaches 5 of the piecewise function x cubed plus 1 if x is less than 5, and x squared plus 1 if x is greater than or equal to 5. Notice, I'm asking you to find the limit at the breaking number, where it breaks into 2 pieces. Yes? That number right here? I call that the breaking number. I don't know if it actually has a name. If it does, I've never heard it, but I just call it the breaking number. So in order to find the limit, you still have to find the left limit. And so what I usually do is I just come out to the side and I say, all right, the left limit would be 5 cubed is 125 plus 1 is, all right, that's your left limit. Right? Okay. This is my right limit, which would be, are those two things equal?
No.
Then this does not exist. Aha. Now I have a really tricky question for you. I know. What's the limit as x approaches 0 of this function? Don't talk, just think.
You're gonna find out.
I changed my mind. We're not approaching 0. Because that's a bad idea. Let's approach 3. Let's approach 3 instead, because 0 would yield the same thing all the way around. Does anybody know? Anybody have an idea of what I should do?
Direct substitution.
Yeah, I think that's a great idea. Let's try direct substitution since nothing weird is going on there. By direct substitution, this piecewise function is telling me to substitute 3 into where? The top or the bottom?
Top,
Why?
because x is less than 5.
Because x is less than 5. Perfect. Okay, so as we approach 3, that only belongs in this piece here, the upper piece, which is considered the left piece, because the 3 is less than the 5. So we ignore this piece for this problem, and we simply substitute the 3 into here. And that gives us 3 cubed plus 1 equals 28. So the limit as x approaches 3 for this piecewise function is 28. The only time you have to plug into both pieces is when you're actually looking at the breaking number like we did in this one here.